Professor Lin and everyone. So welcome to the seminar today given by Professor Charles Lin. Professor Lin is a professor in University of West Ontario, so now called the Western University in Canada, in the Department for Computer Science. So his talk gave us today as the Crafting Your Research Future, which actually based on his book published some time ago. So actually, I know Professor Lin since when I was in West Ontario, long time ago, actually, more than 15 years ago, in 1998 up to 2004. Actually, at that time, I know Professor Lin, even although we didn't have much connections. I know very well because Professor Lin is a professor in computer science. I was in electrical and electronic department as a postdoc, also later on the assistant professor, before going to Denmark in Aalborg University. I joined to Concordia in 2006, end of 2006. It is our great pleasure and honor for inviting, get a chance to have this talk given by Professor Lin. I just briefly talked as a brief about of Professor Lin. Professor Lin obtained his PhD degree from University of Pennsylvania, UPenn, in States. He's currently a professor in computer science and also as a science distinguished research professor at the Western University, Canada. His research is also very popular subject on machine learning, deep learning, and applications, particularly for the health and finance. He also has a startup companies which provide personalized advice using machine learning for people with diabetes. He's also a fellow, most important, he's also the fellow of Kennedy Academy of Engineering. He's published more than 180 papers, and his papers with the student also received several Best Paper Award from AI conference associated with IEEE or other conferences. He also received one of the INSERC DAS Award. He's also keen for the education, particularly not only for the graduate student, also for the high school of the student. So it is our great pleasure and honor to have Professor Lin give us the talk today. So welcome to Professor Lin for your talk. So now floor is yours.
Okay. Thank you very much, Yuming. Thank you very much, Professor Zhang, and thank you everyone for coming. Thank you for the generous introduction. I've been in Montreal a couple of times, but never been Concordia University before. So hopefully, when everything is clear up, I might be able to visit your university and give a talk maybe on my research. This talk is not about my research, but it's about how to do research. So I hope it will be beneficial to many graduate students in all disciplines. So especially in science and engineering. So let me share my screen so that we could. Okay. So I think you can see my screen.
Yes.
Good. Okay.
Everything's good.
Okay. So just want to mention again that you are welcome to ask questions during my talk. You could use your voice, which is preferred. Very easy. Just speak. Just unmute your mic and talk. And then Zoom meeting is actually very good. So today I want to talk about crafting a research future. It is a book published by me and my good friend Chiang Yang. It's called Crafting a Research Future. Now, I'm not trying to sell you the book. So the book is published by Morgan and Claypool. So therefore, it's free downloads for almost all universities in Canada and many universities in US. So if you cannot get a copy or get a PDF file, you can certainly ask Professor Zhang or ask me. That's not a problem. We can send you a PDF version. But this book
is available on Concordia's library. Yes.
Ah, that's great. That's great. Yeah. Yeah. And this book, this book has been published for 10 years now. Actually, it's published 10 years ago. So Chan and I have been thinking about, we have a lot of new materials that could be used for. Oh, I see a chat. So that could be used for a new version. Okay, thank you for all the hearts. Thank you. Yeah. So we are thinking of publishing a new version. So some of the slides presented here are not in the book, in this 10 years old book. And also, if you ask good questions, I might include your questions and answers and all that stuff in the new book, right? In the new version of the book. Okay, so do ask questions. Okay, so I also give talks to my university. For example, several years, I give a very 20-minute talk to all incoming graduate students. So this is the incoming graduate student in each year. We have about 1,000. Also, just want to mention in China, for many universities, I give like summer courses, like a 7-day compact, very compact summer courses on every detailed aspects of the book. So just want to mention that. Okay, so let's get into the real stuff, right? So as a graduate students, we all know that you are here to do research, but I want to mention or make it clear, right? What is research and how to do research? And so therefore there are key components in research, okay? So doing research is very different from undergraduate study where you mainly learn knowledge, you mainly take in knowledge, okay? So doing research is mainly make contributions. You're making contributions, but those contributions must be novel and significant. These two keywords, novel and significant contributions to the knowledge, to the technology, right, to the engineering aspects of daily life. Okay, so what is novel? Novel means new, original, innovative, creative. All these are synonymous. But in academic world, novel means that this has not been published previously in a peer-reviewed venue, such as journals and major conferences and stuff. So if you heard people talking about it, right, but that's not yet been established. Okay, so as long as it has not been published, right, the idea may be floating around, but if you can first get it done, that's still considered to be a novel work. That's because ideas may come easily, but you need to do significant work, meaning that your work needs to be impactful, useful, beneficial, significant. That's the other keywords. Okay, but what does that mean exactly? Well, this is of course a little bit hard to judge at the time of publication because it depends on your writing, right? So at least in the long run, into the future, right? You can say your work is very impactful if it is cited by many people, or maybe your work has turned into some prototype, some product that can benefit millions of people, right? But at least at the time of when you submit a paper, your work needs to be better than the state of the art. Okay? Because if it's not better than the state of the art, why do you do it, right? So that's the usual way to measure the significant impactfulness, etc. And then, of course, how do you let people know that you have made this novel and significant contribution to the knowledge? Well, you publish a paper. You publish papers in a peer-reviewed venue. Now, these peer-reviewed are reviewed by the experts in the field. So, if they judge your work is novel and significant and thorough, then they will say, yes, accept it and publish it. And then when it's published, then it's no longer novel. So other people must then cite your work and keep on going. Okay, so that's, you see this cycle of novelty and significance and publication, this cycle for academics. But I want to mention that this novelty and significance are not black and white. Okay, you cannot just say it's novel or not novel, significant, not significant. It's not black and white. In fact, you can say novelty or significance are all shaded, right? actually in conference review or journal review, reviewers often need to give a score, right? Maybe out of 5, maybe out of 10, how do you rank novelty? How do you give a score? How do you give a score here? So therefore, all these are shaded, okay? So that's very important to understand. So all we need to do, right, is to improve the novelty and improve the significance if we can, right? If one is relatively low on the novelty, let's say, then your paper must be highly significant in order to be accepted, right? If both are low, then the chance will be small. Okay, so it's a balance of the two. Important to understand. Okay, so this is kind of one of the very important understanding of what is called research. In terms of the type of research, right? You can say there is a spectrum, again, a graded area spectrum of very basic theoretical research on one end and a very applied research on the other end. So on this end, you can say these are the R and D. Sometimes people say R and D, and R will be the main component. You want to develop new theory, math. They may have wide and long-term impact. The impact usually for basic research is long-term. And this kind of work, therefore, is usually sponsored by the government. And this kind of research is also usually driven by curiosity. It's not driven by, say, a company's short-term goal. On this end, the research is mainly into the development, and it's usually there is some kind of killer apps, killer application, okay, or very important requirements in real life that you cannot, the current technologies or cannot do. So we call it killer apps, right? Killer apps. And usually then the student, will develop some kind of prototype, okay? And this kind of work could be sponsored by the government, by the industry, and even by the venture capitalists, right? So therefore, this is a sort of more extreme two ends. Okay? And a lot of the research that I'm doing, for example, is kind of, a spectrum in between. So I use this yellow line here. So we may develop new algorithms, new theories, new methods, and test it empirically, right, on big data, right? So I'm in computer science, so software engineering, and mainly dealing with large amount of data and try to do science, do engineering, data engineering on the data, right, in order to do computer vision, medical diagnosis, and all the other stuff. Okay, so maybe afterwards, if your work is at this end, you could probably move into some kind of a startup company, right? Which I actually have done that before, which is a very interesting journey in itself. This is not something I want to talk about today, but this is something that is extremely interesting and perhaps very useful for graduate students as well to think about. Okay, well, are there any questions at this point? Okay, good. If not, I could continue. So first, and then I want to talk quickly about important skills for researchers. Okay, there are a set of skills that are very important for graduate students, especially for PhD students. I want to say, especially for PhD students. Okay, again, those skills are not just yes, you have it, or you don't have it. It's also graded. I want to make sure you understand. So first of all is the passion. Okay, you want to aim high and aim long term. As we will see very soon, doing research is a long-term kind of work because you are doing novel and significant work. It won't be very easy, okay? You need to be mentally strong. I think that's very important, okay? Graduate students often get their paper rejected multiple times, and sometimes people get very frustrated. I used to get very frustrated, okay? So you need to be mentally strong, and you need to work with a supervisor and try to just keep on, pushing and try to get it published. In order to be creative, right, you really need to have a curious mind. Okay, you always are very curious, and you're also very critical. You always want to ask question why, and not only why, also ask question about why not? Why not? Okay, you always want to challenge the current established work. Say, I think this might not be correct. Okay, that's part of your mentality. You always think that way. Can I do better? Okay, you also need to be inventive or creative, right? I have new or better ways to do things. Right? Okay, so this is about novel. This is about significance, right? How to do the significant work. So you need to have this kind of mentality all the time. I can do better. I think that there is a better way, right? And challenge the the established work. As I mentioned, doing novel and significant work is not easy. You need to be focused, okay, and you need to be diligent. Okay. Now, I just want to say that like 9 to 5 is not normally a researcher's will be. A researchers, because of the passion they have, the difficult tasks they are facing with, they are normally willing to, they are keen to spend as many time as they can on the work, okay, on those sort of novel work. So therefore, spending 12 hours plus a day is very normal. For me, it's still right now, but I'm sure Yoming and also many of you, you spend as much time as you can on your dream, on your long-term dream, right? And this can last for months or for years. Okay, so this is very important. Okay, you also need to be quick. You also need to be a quick learner for new knowledges. Okay, you need to be initiative taking, rather than your supervisor tell you, oh, it's better to read this paper, better read that paper. You actually are out there searching, reading, and doing work on your own. Okay. And this is also extremely very important. You need to have a very strong analytical and problem-solving skills. And that's exactly how we can find a better and new ways. Nothing will be very easy, but if you have very strong analytical and problem-solving skills, you can try to you can try to make a breakthrough, right? You can try to find some a new twist, new angle to make things to work. Okay. Last, I want to say, don't think researchers are always just sitting in their cubicle and you also need to be a very good communicator. Okay? You have a good communication skills. You want to be visible as much as you can in your field. Okay, so don't be shy. Go to conference, talk to people, present your work, give talks, right? And you really need to be very visible. You need to have a good verbal communication skills and also written communication skills. And written part is where you need to write the paper, right? Remember, we'll talk about that. And last, I just want to mention briefly, because you are researchers, you also need to have high scientific integrity. Okay, your work need to be truthful, your evaluation need to be fair, and your evaluation also need to be rigorous. Okay, so doing research is very different from like making a product and promote the product. Okay, and then there you can say whatever, right? But doing research, you really need to be truthful, fair, and rigorous. And that's partially because our work needs to be evaluated by other researchers. So if you say anything that is, fishy, other people will very easily find it out. Okay, need to be truthful. Okay, so these are the important skills for researchers. Any questions? I heard something, but okay. Yeah, so again, you can interrupt me. And what if you are weak on some of these and then, well, try to improve, right? You need to be quick learner and you need to spend more time, maybe. You need to try to push yourself, right? So it is something that you need to improve on, okay? So 2 ultimate goals to be graduate students in your graduate studies, especially PhD students, okay? The first goal is as a PhD student or as a PhD thesis is that in an important, right? Because it needs to be significant. So therefore in an important, albeit narrow field, all right? Maybe it's relatively narrow. which is your PhD thesis topic, you are the best in the field internationally. Okay, so that's the first goal, right? Novel and significant, right? Your work is better than the state of the art. Okay, so that's the first goal. This is especially for PhD candidates. Okay. So here I have a graphical illustration. So here I draw a line. So this is the current best, the state of the art, right? And this is an area. So I only use one dimension. It could be AI, it could be deep learning, right? It could be even be like transfer learning in deep learning, whatever. So it could be any of the Professor Zhang's field, right? And what you want to do, so this axis is expertise, right? Is that during the 4 years of your PhD, you want to formulate a curve like this. Maybe during the first year in your PhD, you are exploring several fields and you are interested in some of these fields, okay? But then maybe from the second year, you need to actually pick up something and focus on, and you push your expertise curve up towards the best or better than the best in a narrow field, right? And then maybe after the third year, you are better than the best, but maybe a very narrow field. And that time you can already write papers. Okay, you can already try to write and publish papers. And then in the fourth year, maybe fifth year, you are way above the current best. This is the current best, right? And then you are way above. Okay, and this area above this best line is what we call your PhD thesis. And based on the PhD thesis, you have already published, a number of papers. Maybe you have, a number of patents, right? Especially in the engineering field. And these are your work, right? These are the result, the fruit of your hard work. Okay? One thing you should notice is that, when this curve is going up, you will see there this term we call area under the curve. This area under the curve. This area under the curve actually represents your effort. So that's why I said that 12 hours a day, is very common that you put in a lot of time and effort to formulate this kind of your expertise curve in 4 years. Okay. Now, some students say that is it possible to have a good PhD thesis with little effort, right? Some people say, is it possible in 4 years? So this is the 4 years, right? I could have this kind of curve where I'm also above the best, better than the best, but see my area of the curve is small. I want to tell you that that's no possible. There's no possibility for that, okay? That's because you are doing explorative work. You are doing novel and significant work. You really need to know a lot of areas surrounding the area you are extremely good at, okay? So that's not possible. Another way of PhD student, which I call a poor PhD thesis, is that, you see you have, a very large area under the curve, so a lot of effort. However, you didn't really establish yourself in some field, right? So I say that there's a lot of effort, but no focus, okay? And this may earn you several master's theses, but not a PhD. A PhD is different, right? So see this animation. Okay, in the last animation of the poor PhD thesis is this kind of student. So they spend 4 years, right? You can see that they also have a lot of, very large AUC, area under the curve, but they also break the ground, but very small and in several different fields, okay? So I will say these students, right, they're publishing in topics, different topics, but they are not well established in one. So when people talking about, oh, who and who has graduated PhD looking for a job, but what does he or she done? What has, he and she done? And then people kind of, well, so yeah, any questions? Okay, so when it is not well established in one, and that's also not ideal. So I just want to mention these, there are these different ways. So that's the first goal, okay? In a narrow field, in albeit narrow but important field, you are actually better than the best, and you are focused. in the second goal of a PhD student is that you're becoming an independent researcher. Okay, you do have a supervisor, but your supervisor is, okay, I see a chat. So let me see. Yeah, we hear some background noise. So therefore, if you don't have questions to ask, please mute. But you are highly encouraged to just unmute and just ask questions with your voice. Okay. So the second goal is you become an independent researcher. You know, your supervisor will guide you at the beginning, but then later on you want to do a lot of these things all by yourself. Okay. So here's another illustrative curve. So here's the 4 years. Here the independence. Okay. So what we want is a student is something like this. At the beginning, you know, you probably don't know how to do research, but maybe after you listen to this talk, right, you jump right to here, right? And then, you know, and your supervisor will spend more effort in terms of this is your supervisor's effort. Okay. At the beginning, your supervisor also guides you, right? Including, for example, my talk. But later on, you know, your supervisor effort will kind of does not need to be high, and you can you know, find new ideas. You can write papers yourself, right? Of course, you still have weekly meeting or bi-weekly meeting even with your supervisor, but you are making great progress a lot by yourself. Okay, so be an independent researcher. And early on, we talk about initiative taking, right? So these are the students who need to take initiative. Now, your supervisor may also, you know, give you some papers to review. And these, again, you know, kind of to establish you to be a researcher, to review other people's paper, right? So these are very important kind of guidance or lessons you know, you can say that you are learning to be an independent researcher. Okay. And you can see, because you are doing more and more independent work near your PhD you know, thesis, near you finish your PhD thesis, and normally we say that you are established or own an, you know, an area or that topic, right? So remember, we say you want to well established in one, and because you are more and more independent, and usually at least in my field, when we publish paper at that time, student is always the first author, and student also go to the conference. So therefore, you know, these are the cases where you establish yourself, you become well-known, and you own a field. Okay, I see another chat, so I'll quickly take a quick look. Oh, it's pretty long, right? I have a question. I understand that sometimes working 12 hours a day is needed for okay, when close publication, but not how we make this sustainable working life difficulty. Okay, yeah. Okay, so by reading this question briefly, I think the student is, or the person is asking, right, how do we sustain 12 hours a day for a long time? Well, I want to say that probably, I mean, the more I would say, the better. Of course, you also need to achieve life-work balance, right? And you probably take 1 day or, you know, 1 day and a half off during weekends to actually completely have fun. You know, you can have your exercise machine at home or go to the gym. You know, efficiency is very important. So even when you probably on the treadmill, right, you might still think of the problem. You know, so when I say 12 hours a day, it's something that you are constantly, it's part of your life, to put it another way. Okay, and especially, well, I mean, when you need to have work-life balance, of course, you need to have that, because you want to have an optimal mentality and health, obviously, right? But you don't want to waste time. That's what I want to say. Okay. Any other questions? Yeah, let's see another question. Okay. Continuous is the word, right? Here's what,
Professor,
yeah.
may I ask you a question?
Please, yeah. Asking question in voice is better, so I don't have to read. Yeah.
Okay. So I'm a fourth-year PhD student at Concordia in engineering, and when you showed the poor student profile, I felt like I'm one of those. And I mean, I don't know what I should do about that. And when you showed the curves of the student and the supervisor, the thing is, my supervisor has a very jumpy curve as well. He's not always there, you know.
Okay.
My supervisor also hasn't provided me the support in the first years that he should have. And I don't know, I have to find a way to become the independent researcher. Where should I start?
Yeah, so I know that this could be a problem. This could be an issue. This could be a challenge for some students. I actually completely agree. Every professor is different. Some professors, especially some professors, especially big name professor, you know, they don't necessarily, you know, work with their students that closely. That could happen. And I think what you need to do in this case is just try to find the best way to cope with this situation. Right? There may be some other faculty members, either in your own department or university or in other universities you can work with, right? You know, and also if your professor does not provide a lot of guidance, right? That's why I think this book or this talk could help. But if you listen to this talk, 4 years ago, maybe you could have been doing better. It's hard to say, but the point is, you just grab whatever is available for you to your advantage. That's what I want to say. But good question. I mean, this is a very real situation.
Thank you.
Really understand. Yeah, sometimes there's no perfect solution, right? But do try to find the best out of the current situation is what we can do. Any other questions? Thank you for your question. Yeah, asking question this way is more preferred than a chat. Okay. Of course, when I was describing is sort of more ideal situation of PhD student, and I want to tell you that I also have 1 or 2 PhD students that graduated in 6 years, 7 years, and I pushed and pushed, and sometimes nothing worked. So every person's situation is different, and it's very hard to. But here I'm describing a more ideal situation, and also efforts towards that. So. Good. Thank you for the question. Okay, so let me continue. So 2 grand goals for the PhD, for an ideal PhD, I would say in 4 years, right? So having something like this and also become independent. Okay, so that's and again, as I mentioned, it's not very easy. Just your question is mentioned, right? So your supervisor, is not providing enough guidance, etc. That's not very easy. I completely agree with you. Okay, so. One thing to do is, of course, to try to understand the difficultiness of achieving these goals, but try to break it down into subtasks, divide and conquer. Okay, so in order to achieve this goal, a PhD or especially a PhD thesis, you want to break down into 3 tasks. Okay, one is find novel or new ideas. Remember when we mentioned novelty? So find new ideas, novelty. The second task is called do solid research. This solid means impactful, meaningful, right? Significance, right? To verify your ideas. And the third, as we mentioned, you need to publish top papers. You need to publish good papers. Okay. So this is an iterative process like that. These 3 tasks, and master students usually iterate 1 or 2 times and finish. Okay, but PhDs usually will iterate 3 to 6 times, try to publish several papers in the same broad field, okay, in the same field. So that way, you can establish yourself, and then you go to your master or PhD thesis, and you become a successful researcher. Okay, so that's the 3 different subtasks. Okay, so I want to talk very briefly about the future after PhDs. So let's say you have got your PhDs, and again, after you get a PhD, you also do novel and impactful work, and more or less independently. And that's why these goals are very important, because the future is you are also doing similar things. That's why. Okay. So of course, one career path is academics, just like Professor Zhang and I are faculty members. So we are educating university students, right, to graduate students to become researchers, and after they graduate, they may also become academics, right? So do impactful novel work, independently. And we now don't have any supervisor, so of course we need to do work independently. The second potential path is entrepreneurs, right? Because your work is close to some kind of impactful prototype products. Maybe you become entrepreneurs, and I've been there, and it's extremely competitive and very interesting experience, I want to tell you, but I won't talk about too much today. The third is in most very large companies, right? You can be hired as a chief scientist or chief or senior engineers, okay? And these are the important work you do for the company. You also need to do novel and impactful work independently, right? Because you are the, one of the best, scientists or engineers in the company, right? So therefore you need to do those work. Now, probably when those companies hire you, especially big company, they will give you some, shares, stock options, stuff like that. So you become part of the company, right? So these are all what I call careers. It's your work, right, is part of your life, you can say, right? You work for yourself. You obtain the results as part of your effort. Okay. Now, what at least I hope not to see is a PhD after graduate just doing a normal job, right? A 9-to-5 paid job, and that's something you try to stay away with. Okay, you try to be one of these. I think these are because we are trained to do these things, so therefore you can be one of these. For doing a normal 9-to-5 job, paid job, you are doing the work by being told what to do, right? There's no novelty there, virtual. So, okay. So these three subtasks are all described in this book. Chapter 3 talk about finding new ideas. Chapter 4 talk about doing solid research, and chapter 5 and 6 talk about publish top papers. Okay, top papers. So and chapter 7 also talk about write and defend PhD thesis. About that. Okay, so you can again download the book for free and read. Okay, now in the remaining time, I want to talk about some major mistakes in the 3 steps, in these 3 tasks, some major mistakes. Okay, because again, I can spend 2 hours on each of these, but I want to talk about very quickly some major mistakes. I want to talk about one major mistake in each step. Okay, so in the first step, right, finding new ideas. Okay, when you need to find new ideas, of course you need to first read papers. Okay, I want to say that quite often a graduate student, especially at the beginning, when they read papers, when they read recently published papers, they spend a lot of time trying to understand every detail of the paper, and I think that's a mistake. That's not a good idea. Okay, and that's because reading a research paper is very different from reading textbooks, like in undergraduate study, when you need to understand the material absolutely, correctly. So what I advocate is you spend relatively minor amount of time try to understand the main ideas and solution. Okay, don't need to be every detail, enough detail, but the other 70% of the time while you're reading the paper is to do critical thinking, right? Think, what's wrong at high level, of that paper. Is the assumption is not good? Can I do, is the author using the best approach, right? Can I find counter examples, right? Critical thinking, okay? The other is called creative thinking, okay? What else I could do? Why not the author tried that way, right? How can I do it better? Okay, so these are all creative thinking while you are reading the paper, and you are doing more of that than this. Okay, and that's of course partially because people have already, other research have already published that paper. So completely understanding the paper is kind of useful, but it's already been done. You need to do better, right? You need to do better. The other thing is, the more you read often, the more your mind is constrained by that paper, right? So you want to sort of think out of the box rather than stay in the box too long, okay? So, it's very important, I think it's very important to form a habit of critical and creative thinking. It's a form of habit, not only in reading papers, but also in daily life. So, I also do a lot of child education work, including my own children. And also I went to public schools, elementary schools, grade 3, grade 4, grade 2, volunteer my time in teaching kids for critical and creative thinking, right? So something I do with kids is sort of watching a movie, of course, but not just watching the whole movie. For example, like a science fiction movie, Back to the Future, right? So rather than watching the movie, right, I will stop the video during the middle and say, what's wrong of that movie, right? What's wrong so far? Or kids can raise their hands, right? Or how can you continue the movie? How can you do it better? Can you be better than Spielberg, right, in directing and continue this movie? So this kind of training, even at a young age, is very important in order to have this mentality all the time, right? So I like to use science fiction movie because they normally have a little bit of assumption and then change the assumption and carry on the story. But then you can always find contradictions or plot holes, and you want to find out these plot holes, right? So there's also a movie about the Da Vinci Code, right? There's a lot of plot holes there, and you want to find what's wrong with this movie and how can I do this better, right? And of course, there is Inception, right? There's plot holes inside holes. So doing this kind of regular thinking mentality exercise is very useful. I need to be a little bit fast. So you also want to be critical to your own work. It's very important. Okay, so because your paper will be reviewed by other reviewers who are also critical. So when you submit or write your work, you need to be extremely critical also to your own writing, right? Make sure you can answer other reviewers' challenges and questions in the paper, right? Because you don't have a second chance. Okay. So this is very important to understand when you read a paper to come up with new idea. See, this allows you to come up with new ideas, right? So don't read a paper too carefully, but try to come up with new ideas. Okay. I want to move a little bit faster. Okay, so the second question, the second major mistake in doing research, when doing so that's the first step, right? In the second step, in doing research, is that the new idea, maybe the new idea came from your supervisor, maybe the new idea came from you when you read the paper, right? When you try to do solid research, does not work. Therefore, I quit. Okay, so the idea doesn't work. Okay, so this happens very often. So now, when you're probably in high school, right, you do science fair project, the new idea is almost like a new hypothesis, something that may or may not work, right? So we have been learned, right? We have been told to, well, when you have a hypothesis, right, you simply try to confirm it or reject it. Confirm or reject. It's like a binary, right? But in doing real research, it's not like that, okay? So first, I want to say that you want to start with the most obvious, most direct, most effective hypotheses or solutions, right? Don't just start with, this is a very popular, transformer is so hot these days. Let me just use transformer to solve my problem, whatever that problem is. So there's this saying that when you have a hammer, right, everything looks like a nail. So if you have some sort of recently published work like a hammer, you want to apply to everything, or you want to apply a complicated method to some relatively simple problem. I think that's not good. You start with the most obvious, direct, and effective way. And if it doesn't work, you can work up for a better or more sophisticated solutions. Okay. And that's exactly I want to talk about. When you come up with a hypothesis, a way to solve a problem, there are actually 3 cases usually could happen. The first is that you can indeed directly confirm it. But I want to say that this is a very usually quite rare, only 10%. Okay, only 10%. Most of the time, I will probably say 70% of the cases that you must modify your hypotheses and solutions to find a way, an angle, an assumption, right, to make that work, to get that work. Okay, so you start with the most obvious direct solution, and then you try different ways and try different. So, and this you need to. This is probably 70% of your time and effort, and that's exactly early on when I say, analytical. I want to say that word 3 times. Analytical and problem-solving skills are extremely important. You want to analyze, the result you have, break it down, find out why it didn't work, and how can I make some small changes here and there? How can I try different things? And you will spend a lot of your time in this here. Okay, so it's a dynamic process. And of course, after you tried, weeks and perhaps months, still didn't work, then it is possible that you quit and move into another problem. Okay, so again, scientific research, right, is never been anything certain. There's always a certain percentage of the time it didn't work. Right, but if you try hard enough here, you can get most cases to work. But still, it is possible. Right, nothing will work. Okay, so do spend a lot of effort and time in this part. And how long, you try this before you quit? Well, everybody or every supervisor, every kind of research is different. But in my own experience, usually half a year, if you couldn't solve something, then you should probably switch. At least, okay, for my students. So that's the research aspect, okay. In writing papers, the 3rd task, okay, there's also some sort of major mistakes. The major mistakes is something like, well, I'm a little emperor, right? So it's a PhD, is very sophisticated. So here's a Chinese emperor, here is a Rome emperor. So here's what some PhD student will think, it is your responsibility to understand my paper, right? So when I write a paper, I don't care in a way how reviewers, it's there. You should appreciate the work, right? And some students even say that, well, if my paper is too easy to understand, then it must be too simple. So these are also a common, misconception some students will have. They don't put into effort, try to get their paper easily understandable by reviewers. But how to make that happen, right? How to make that happen, right? Because it is a PhD thesis, right? It is a PhD thesis, therefore, it has sophisticated components, okay? So let me skip this again, I want to skip some of that. So I want to say that the important aspect of writing a PhD thesis or any paper is called top-down refinement. Okay, top-down refinement. Top-down refinement means that when you write a paper, of course, you will have a title, right? And then, of course, the title will be expanded. So that's why it's called top-down refinement. So you make the title more concrete, right, by writing an abstract. And the abstract, I will say, is about 200-word story. So I use story, meaning that the abstract should be very easily understandable by almost everyone who is subscribing or who is reading that journal or conference, who are attending that conference, okay? And then this abstract is further expanded, top-down refinement, into perhaps a 2-page introduction. And this 2-page introduction is also, I call a story. I also call a story, right? A story is something you can tell any sort of university students, not necessarily people on the street, right? Because it is academic work, but a university students, you tell him or her your story. And I will say your introduction, you should try to make it such that about 75% of the people that usually attend the conference or reading that journal should easily get it. Okay, so don't use a lot of technical jargons, etc. here in the introduction yet. Okay, and then further top-down refinement, then you will refine your methods, right? Refine things further into different sections. You have section 3, section 4, section 5, section, etc. But at the beginning of each section, I would say introduction of each section, right? You also need to have a high-level summary of that section, and that you need to have about 50% of the people understanding it. Okay, and then of course when you discuss like 3.1, 3.2, 3.3, then these are more details of the section. Then maybe even fewer people can completely understand it, but that's fine. You see, people already understand a lot about your whole picture. Okay, and then then maybe you have 3.1.2, or maybe an appendix that you contain really technical stuff, proof, math, whatever, right? And it's there. Maybe only 15% of people can understand, but they are hiding under 4.2.6.2. So when people read the paper, they will naturally already understand a lot of the high-level stuff. The best paper with a proof is that people don't even need to read the proof. They know that your proof is correct or your theorem is correct, right? People don't need to read math derivation. They know that you have a solid foundation. And that's all these high-level descriptions there. Okay, so that's what I strongly advocate when you write very technical paper, this top-down refinement methods. Okay, so that's why, again, maybe every field is different, right? Every field is different, and at least for AI, for deep learning, you need to write paper this way. And of course, when the conference is highly mathematical, then people are used to have very mathematical definition to begin with. Actually, I even discussed this with professors in math department. They have different convention, at least, right? They want their paper to be absolutely formal. The more formal, the better. But I asked those professors, I say, do you understand, how much time do you need to spend on reading that paper where you start with definition? They all sort of, it's very hard, but that's kind of the convention in the department, in a math branch, which is, in my view, unfortunate. Anyway. Okay, so that's the mistake, often a mistake that when you write paper, and I hope that you will use this kind of top-down refinement in writing a paper. Okay, so I think time is just about right. So I want to reiterate the whole process, okay, combining. So first of all, in order to do a PhD, you need to intensely interested in some topic, okay, and you maybe at the beginning a few topics and you explore them. And then you start with reading survey papers, you take some courses, and then you read recent paper, you do Google Scholar search, and you try to understand the field a lot, okay? And then, of course, you try to find new ideas, right? Novel ideas. When you read very recent papers, and you want to be critical and creative along the way, so you can come up with many new ideas when you read papers, okay? And then you want to verify, before you do the work, usually, you want to verify those new ideas by talking to your supervisors and colleagues, start more thorough, literature search, because maybe this has been done, your idea has been done. So you really want to do more thorough research, literature search. And then after that, then you want to do solid research. Then you formulate your problem, you study deeply, you do trial and error, right? Remember, you really need to modify your hypotheses, trial and error, etc. You evaluate your results, you really improve your results, And you may need to go back to 3 and 4. Okay, you may need to, maybe it didn't work, right? Maybe, so you need to twist the idea, you need to, talk to more people. And it's an iterative process here, in a few steps. So maybe after, several months, then, your idea seemed to work, right? Your idea is, produce, impactful result better than the state of the art. Then you need to write a paper. Okay, you need to write a paper. Now, I often find when I try to write a paper, I also need to go back to 4 and 5, because when I, write papers, it's a time when I organize my logic, when I try to make an argument, when I try to make my paper not attackable by reviewers. Of course, a reviewer can always attack. But I try to. So therefore, I often say, maybe I need to do some more experiments. Maybe I need to do this. Maybe I need to add more data set, to make my paper more solid. So when you write paper, you also sometimes often need to go back to those fields. Okay, and then after your paper is done, right? Then these days, at least in AI, machine learning, it's very competitive. It's highly competitive. Unfortunately, we have this archive where you can sort of dump the paper there by saying that I've done it, right? And at the same time, you sort of send it to colleagues and conferences and journals. So you want to archive it. So that saying that I've done it, I'm the first, right? So do that, and then you send it to conference journals, and then of course after that you go back, you go to step 2, right? Maybe you expand or deepen the topics that you have worked on, so that your PhD will look like that, right? So you continue on this, okay? So in summary, I just want to say that hopefully this whole process will form this kind of shape. Hopefully you become a more independent researcher, right? And these are the 3 steps, right, of that. And I discussed some flaws, most common mistakes in each of these steps. One common mistake actually. And then more details could be found in this book. So timing is just right. So thank you. And I want to see if there are more questions there. Thank you. That's it.
Thanks to Professor Lin for very inspiring and informative.
Thank you, Yumin.
Very good, excellent talks. Give us very good views of that creative thinking, and for the paper writings with that suitable logic behind all the details. Thank you very much for wonderful.
You're welcome. You're welcome. Yeah. Mm-hmm.
Yeah. Okay. So now I want to ask some of anyone have any questions.
Yeah,
so
there's the one chat. There are 2 chats. So let me try to read it.
Yeah. Okay.
One is for thank you for a great talk. Also thank you. Okay. So both are thank you. Thank you. Thank you for your comments. Very good. Okay. Thank you. Thank you, Jasmine. Yeah. Mm-hmm. Thank you for the great presentation. Would you share the video? Yeah, I can. Well, Yumin is recording. I'm also recording it. So I'll send my link to Yumin, but Yumin will probably have a YouTube link as well. So, but I usually post my talk in YouTube. So, yeah, I will certainly send the YouTube link to Yumin, and then you could share with other students. One more chat.
This is my colleague actually. I have 2 colleagues, professors. You say that Professor Mutu, and also Janison. Also, it's my colleagues actually in my department.
Great. Yeah.
We also attend this.
Please do ask critical questions. The same thing. Criticize me. And I'll be very happy to see if I can answer it. If I cannot answer it, I will study more. So please do.
Charles, first of all, congratulations to you. Actually, you've done a very good job, because you really share a lot of our pain and views on how the students can improve. I think whatever you shared, I could resonate every slide of yours. I could see that you are speaking my mind out there. I really feel that way, that I think you've really done you've done a great service actually in terms of helping the students as well as faculty too, in basically what the student should expect And I think if students go through this before they start any graduate work, I think it'll really help them in terms of preparing the mind, the mindset. I think it's all about the mindset, as you mentioned indirectly in your slides, is developing the mindset towards PhD. PhD is not any other job, any other study, as you said. Perfectly, you said that. Very good.
Yeah.
So,
Thank you.
think,
Thank you. Yeah.
I think that's exactly, because it is not another master's. It is not an extension of a master. It is a different, it's a different mindset and different study. I think you said it very well. I like your graphs of how to exceed in few areas, beyond the expectation of that area, which is excellent. I think it's true for any area, and it's very general to any student, which is very good.
Thank you.
And so thank you so much for this work. It's really very wonderful, and thank you.
Thank you. Thank you.
You for also attending this talks. I saw you over there driving when you listen to the previous talk. Thank you for attending, also support to this talk.
Thank you.
So any other questions?
Any other questions or comments, or or criticism? I welcome all these.
Also mentioned, this is so much subject dependent. There's no one solution to this. It varies on student, it varies on professors and subject nature. So many possibilities here, but overall, whatever is said is perfectly right. It says the student have to be a little more careful and smart to adjust to the situations and find the best of what is available to him. I think that's right. Bottom line. You brought it out. It's excellent.
That's true. Yeah. Yeah. So actually, my experience, actually, sometimes younger, perhaps assistant professors usually work much more with students because they want to have as much publications as they want, before they are tenured. So
it's also, I think they have more time at that time because they have less students to deal with, less students to deal with.
They usually have, some relief of the courses and stuff.
The family will be smaller at that time. It's a lot of personal things also. Is that once you grow older, become a serious professor, you already have more students, more commitment in your job.
That's right.
Your family also demand quite a bit has gone up by the time, and it's tough for everyone. It's not only for one person. It's tough for everyone on that.
Yeah. Yeah. But I also mentioned that being a researcher, the reward is also large, right? Even though it is competitive, but for academics, we all have vacations. We all have summer vacation. We have tenure. We have freedom. We have freedom of doing whatever we want. So that's really a reward, right? Yeah. So
you said it very nicely about engineering, because as an engineer, when they do PhD, at least true for my area of research, I do micro nanotechnologies.
Okay.
Every thesis can become a company. Every thesis can become a product and useful for the company. So I always tell the students, think beyond what is normally available to other students, because you could take it to differently a new height.
Yeah.
You covered it very nicely.
And we need to tell students, being an entrepreneur and start, doing a startup company, right? Yeah. You could become, not only very fulfilled, but also you can become multi-millionaire or billionaire much quicker. At least there's a chance, right? So everything has some payoff and have reward. It is always quite rewarding when you do some work that is inventive, that is really you have passion into it. So therefore, it is much more rewarding than you just do a 9-to-5 job, which is
that's true.
Which is okay, but
Definitely, there's not a must to do that. There's a lot of scope beyond that, as you said. Right. There's a much scope beyond that. Yeah,
that's right.
So one of the drawback I always find it with the engineering faculty is mostly these are international students, as you've been seeing.
I see.
And when they finish PhD, they want to get a job somewhere. They want to start somewhere, and that's the way most of the students get dragged into like 9-to-5 jobs, then taking it much seriously to the next phase. Because of that, you don't have the background support here to, if you want to venture into companies and stuff, they need some support for some time to be independent too. So, but there are supports available right now, as I understand there are supports are coming up, and government supports are coming up now. Incubators are coming up in universities now. I think the students can definitely venture for some time and explore.
Yeah. Yeah, absolutely. Like in Ontario, we have provincial support for startup companies, and there also angel investment. So that's how I started. Spent 3 or 4 years on some startup company. So,
Thank you.
Yeah. Thank you for your comments.
Thank you for all the discussions and and also, Charles, I say one of the questions on the chat.
Okay. Oh, there's some more questions.
Ask you, could you please explain again what is archive?
What is what? Oh, archive.
You mentioned archive because that's also the. I know because you mentioned in the computer science field, people publish that paper in the archive very quickly, as early as possible. But in the engineer field, we still a little bit hesitate to do that because of copyright issues.
I see.
When we upload there, then submit to the journal. Some journal we have the conflict requirement. So could you explain a little more about that?
I see. So certainly engineering is a little bit different. I understand, and in engineering, probably patents very important. So as far as I understand, in U.S. patent, there is a 1 year kind of leeway, right? So you could publish the paper, but within a year, if you apply for a patent, then your IP is still protected by that patent, if I understand correctly, right? So that way you can still protect your intellectual properties, still potentially gain from it while publishing the work. But if you are going to a major company, they probably want to scrutinize very carefully your publication to make sure that the company have an edge, right? So have patents and protect it. So the requirement, I think, for sort of more scientific side of the work and more engineering side of the work is different. But patents are readily available for engineers to apply, and so I think that's probably happening much more frequently in the engineering department than science department.
Yeah, that's true.
Yeah,
that's very true.
Yeah.
As you said, students have 1 year. As you said, students have 1 year grace period now to file the patent after publications, which is actually it's good. No, that's definitely they can publish it. Yeah.
I think ultimately it is. I mean, patent or paper are only they are important, but they are short-term, milestones, you can say. But in the long run, you want to see your work really, benefit the society, benefit people, right? And during the time, of course, you will also be rewarded with, good income, stock option, and all that stuff. So therefore, all these, you need to work for long-term, also work hard for long-term goals, and that's perhaps more important than short-term milestones like that.
That's true. Yeah.
Actually, Moto have most largest number of patent applications in my department, in our department. Actually, you got that. What is that award you got last year? I cannot remember, Moto.
Yeah. Like in my department, of course, we also have. I've also discussed patents with other, my patent officers at the university. But we usually develop softwares, right? Or algorithms, and it is extremely difficult to patent anything anyway. So therefore, we treat those as a trade secret, right? So essentially, these are behind the server, in the. So therefore, people can, just like Google, people can utilize search engine and all that, but they just don't know how it works.
Okay. At least it's easier for us when you work on pure engineering. It's much easier in that sense to patent it.
That's right. Yeah. For engineering, certainly patent is a way to go.
Thank you. So any other further question from the audience? Is there no question? No further question? It's a good opportunity to ask directly to Professor Lin.
No.
And also the other issues related to deep learning or this AI issues also, it's fine.
Okay. You mean once you put the YouTube link, let us know, because most of my students, I couldn't see them, but I want to send them to my students, you know.
Oh, okay. Yeah, I'll send the link to Yumin for sure.
Yeah, I think, yeah, channels will be put on the YouTube.
Yeah.
Because I know the YouTube also have the limitation of the how large of the size, unless you apply for the large amount of videos to be uploaded, right? Is that right?
Okay. Yeah.
Well, maybe I started early, so it seems that there's no limitation for me yet.
Okay,
Yeah,
that's
so
probably
certainly,
because I try to upload sometimes
it should be okay.
videos if longer cannot upload on the YouTube.
Okay.
Except that pay or payment or some permission or something.
Okay.
Anyway, I'll try to make a link out of that.
It's also, I've been planning to meet you because from the CAE convocations, I think we were there at the same time, I remember. Is that right? When we inducted into CAE?
Yeah.
Yeah.
I think 2016, I think.
Yes,
I think we were
longer.
there together.
Oh,
We were
really?
together.
Oh, I kind
we
of.
were
Yes,
there.
we together all of these titles. Almost.
Yeah, so we were
Oh,
together.
sorry,
So
I didn't remember, but yeah, congratulations to you as well.
Yeah, you too. And you tried to visit my lab after some time when you came here, I guess. And
Okay, yeah.
Yeah.
We can talk about how deep learning could be applied in some of your engineering work.
Yeah. Thank you.
Absolutely, yeah. Fantastic, yeah.
Yumin is doing a great job here. He has been trying to connect people and has been doing extremely good work in our department.
Oh, thank you. Thank you for your very strong support always time. That's my best friend, actually.
Thank you everyone for listening. And if you have further questions, you can email me, right? And I see another thank you message from someone. I cannot see the name. Oh, Basak. Yeah. So thank you. Oh, Basak, that's you. Okay.
Okay. Is there any more questions want to ask?
Okay.
Otherwise, I think all thanks to Professor Lin again.
Okay.
Very wonderful.
Thank you, Yumin, for organizing
talks to us. So later probably this time just give the general, because that is for the different field, different subject students for how to write the papers and also for the good works of the PhD thesis, and not include also master thesis as well. So, but probably later, if you have time, give us the research work of yourself related to deep learning AI. In my group in Concordia, we also do a lot of this kind of work.
Okay.
So we try to use the AI or deep learning method for the UAV applications, for first of all monitoring applications, for this different applications, combining with a model-based method.
Right.
So even I worked on that even more than 20 years ago. When I was even in states in West Ontario.
I see.
I work on that neural network. Neural networks not go to that more extension for that. Probably we'll invite you later.
Yeah.
So thanks also to all the professors and the students for attending this talks. So if you have any further questions, you can send me the emails or just we can talk later. Thanks again for your wonderful talk.
Okay.
Thanks to everyone.
Thank you, everyone. Okay.
Have a nice day. Bye bye.
Okay.
So we just
Bye bye.
finish now. Thank you.
Thank you, everyone. Bye bye.